Hey, let's learn about types of chemical reactions. The thing that you're going to need to know is that there are only five. So two of them look a lot alike. One's the opposite of the other. Other two look a lot alike, and the fifth one is a little bit different, but there's only five to learn. The first one is called a synthesis reaction. A synthesis reaction is when you have two or more reactants to form a single product. Remember that reactants are what start a chemical equation. This is before they react, and a product is what you get when you're done. The basic format is that you've got something and something else, and they form a compound. So here we've got some sodium, some chlorine, never mind why it's a Cl2 right now instead of a Cl, and that's going to make sodium chloride. So we have two things making one is a synthesis reaction. We have two things making one is a synthesis reaction. The other one is basically, like I said, the opposite. So this is when something breaks down. So we have a single something here, and it breaks down into its components. We have water breaking down into hydrogen and oxygen. We have calcium carbonate breaking down into calcium oxide and carbon dioxide. So in each of these cases, we have one thing breaking down into two, and it could be two or more. So synthesis and decomposition are opposites of each other. Next, we have what are called single replacement reactions, sometimes called single displacement, which is typically the word that I use. So if you hear me say displacement, don't worry, it's just replacement. This is when one element swaps places with another. So I'm going to underline the cations. Those are the positive. Now I know that B is a cation because it's written first, and I've done enough of these. I know this is going to be a cation, but don't worry. And then the anion is definitely the second one in the compound, so that one I'm going to mark green. And what you can see here is that in this case, A displaced or replaced B in the compound. I could definitely not get an A and B afterwards because those are two positives. So this is when something swaps places with another. So in this case, we have two metals, and we have an anion called nitrate. We're not going to get into those much, but it's there, and the metals have swapped places. Swapping places is a single displacement reaction. In this case, it's a little bit weirder to see, but we have potassium and hydrogen and oxygen. And the potassium and hydrogen have swapped places, sort of. It swapped with one of those hydrogen. So don't get too confused about the details of exactly what went on here. Just recognize that it's kind of like having dance partners here. And okay, such a good thing I'm such an artist. Okay, there we go. And we have McFly replacing Biff. Okay, I just dated myself. That's an 80s movie. But if you have a couple and somebody steps in and replaces or displaces, that's your single displacement reaction. And I'll do the same with the double displacement. This is when you have cation, cation, anion, anion. So notice that I have two compounds here, and something has swapped places. In this case, it looks like the anion swapped places. So the D and the B switched places. We have calcium over here. And if we mark it out, you can see that I've got two compounds plus two compounds yields two compounds plus two compounds. So that's a double displacement. I have a compound, 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 compound. When you see that format, you can probably guess double displacement, and then you can just check and see which ones displaced each other. So our double displacement is when partners swap, or it could be the girls or something. So I guess it's square dancing. Yeah. And then the last one is combustion. This is what you would call burning. Okay. This is going to give us our heat, our light, that sort of thing. What you always get is you have a fuel which has hydrogen and carbon and oxygen, and it always produces carbon dioxide and water. So this is our fuel. This is methane. Natural gas comes out of your stove, cow farts, etc., and that will react with oxygen to form carbon dioxide and water. And it's a little weird to think that burning natural gas, burning paper, burning anything releases carbon dioxide and water. The water is usually vapor, so we don't see that. It goes up into the air. When you eat sugar, that sugar is your fuel. You combine it with the oxygen you breathe, and it forms carbon dioxide and water plus heat, which your body uses for energy.